Let's have a look at the most common hygienic design mistakes. And I have a few categories to share with you today. First of all, drainability. And let's focus first at drainability of pipework, because that's where we see a lot of things go wrong in our food factories. Here are some examples of pipes that are not constructed in the right way. At the top, you see a pipe which is bending. And because of this, there will always be standing water at the belly of the bend. And if this is not drained, over time it will result in the creation of a biofilm, and you will get spoilage, or even worse, a contamination with pathogens. In the middle picture, you see a pipe which is bent to go around a ceiling support, for example. But again, if it's not drained, you are creating standing water, potentially with product or just with water after cleaning, and it will lead to the formation of a biofilm. And last but not least, also at the bottom, if you have like a pipework that goes up and down again, you will create pockets where there will be air traps, and then standing water will also occur as a result. So you should always take care of those situations. A good design for your pipework is to have pipework which is sloped at a 3-degree angle, certainly if the distance is longer, so that it always drains to the lowest point. And if there is a support that you need to go around and there's no other way, you actually should do what is shown in the bottom picture. You should include a specific drain valve at the lowest point in your belly, so that after cleaning you can actually drain this pipe and make sure it's empty and there's no standing water, and you really minimize the risk of the creation of a biofilm. Another area in terms of drainability are tanks. Unfortunately, we still see a lot of tanks that are not of a proper hygienic design. And here are two examples. In the left tank, you see that the outlet is not at the bottom, and hence the red or amber part of the tank doesn't get drained. And the same thing is true for the tank that you see on the right hand side, because that's where the drain is at the bottom and it is nicely constructed, but the pipe actually sticks into the tank and hence creates a level that never gets drained. And in both cases, product remains can stay there, but also chemicals can stay there, foreign objects can accumulate there, and the biofilm will grow. So it will actually create multiple problems for you. Here are some tanks that have a proper hygienic design. First of all, they have the outlet at the bottom. And the left tank, as you see, has a slightly curved bottom, which makes sure that any water still goes to the drain. And the tank on the right, again, has this slope of the bottom of about 3 degrees, which makes sure that any liquid which remains neatly flows to the exit, to the drain. Here are two other typical designs, and that's where you have a curved shape of the tank bottom leading to a central pipe, so that any liquid will always drain fully from the tank. Only those tanks are of a proper hygienic design. And in terms of drainability, also valves are really important to look at. You might say, well, if I have a hygienically designed valve, everything should be okay. In theory, this valve that I show here is a hygienically designed valve, but it's installed in the wrong way. As you can see in this valve at the bottom, there might be remaining liquid. So you still can create a biofilm and can get a problem over time. So the only proper way to install this valve is actually to rotate the valve with 90 degrees. And then you get this picture, so where the liquid really goes through the valve and drains properly downward. So with valves, for example, the orientation of installation is equally important to the hygienic design of the valve. Another area of common hygienic design mistakes is cleanability. And cleanability really starts with the construction materials that are used in your site. Because first of all, of course, they need to be compatible with your product. Sometimes you might have food products which are slightly acidic or are more alkaline, and that requests a different type of material. Also your process conditions. If you have very high temperatures or even very low temperatures for frozen products, yeah, it requires a different type of material. In some processes you apply a lot of pressure to your product stream, and again that requires certain types of materials. But also the environment that these materials are placed in. Is it a humid environment? Is there a lot of water, or is it totally dry? It really determines, again, the choice of your material. And also a very important aspect to consider is the type of cleaning agents that you will need to clean your product and the cleaning protocols. For example, if you have a product which is fatty, you will typically use alkaline cleaners to get rid of the fat. But if you have a product which results in, you might say, the deposition of limescale, then from time to time you will have to use an acidic cleaner. And not all types of stainless steel go very well with acid cleaning agents. So you really need to consider what is the cleaning application and the type of material that you're going to use. In any way, the materials of construction that you use in a food factory, they must be inert. It means that they should not interact with the food or with the chemicals that you use for cleaning of your process installation. They also must be non-toxic, because there might always be a small transfer, especially in plastics, for example, of some of the ingredients which are in the plastic into the food. And those should not introduce toxic effects into the food, of course. And last but not least, of course, these materials should be non-porous and non-absorbent, because any material where liquid or foodstuff will come into small crevices or into the material, you are actually creating a harboring spot for bacteria and potentially even feeding them there, so you will create big microbiological issues over time.